Okay, guys, I think we better kick off and hold to some form of schedule. We'll have some more people drifting in as we go along. So, thank you for coming along to this panel discussion around IoT security. For those people who are in the last presentation, it kind of took a bit of a left turn into security anyway. Hopefully in this presentation we can go a little bit deeper into some of those topics. We'll try and keep it quite interactive. Want to hear questions from the audience, so please shout out and we'll try and answer those the best we can. So let me do some introductions and then enable the panel to introduce themselves as well. So there's the five of us this afternoon. My name is Hayden Povey. I'm going to be the moderator. I'm the CEO of a company called Secure Things. We've been working with Renesas for the last 12 months or so around the new Synergy platform and implementing a lot of the new security technologies which are being introduced in the new platform. We'll be demonstrating some of those on the show floor over the next couple of days, so please come and talk to us about those. Prior to setting up Secure Things, I owned all of the security technologies at ARM. So I ran everything from the secure core processors up to the trust zone security technology in the application processors. And previously to that, I ran all of the microcontrollers at ARM, so the Cortex M3, M4, things like that are all my fault, so I apologize in advance. I'm also on the executive steering committee of the Iot Security Foundation, which is a new foundation which has been set up in the UK by the National Microelectronics Institute, which is the governing body of UK electronics. That foundation is not strictly for the UK. We're already taking memberships from the US, from Europe, and from the Far East as well. So that's meant as a body for best practices. But we can come back onto that later on. So what I'd like to do is introduce the panel. Perhaps we'll go from right to left as the audience looks at you. So starting with Steve.
Hi, everybody. Good afternoon. Welcome. Thank you for joining the panel today. So I am Steve Delaney, president of Cipher Bridge Systems. We've been in business for going on 10 years now, and our business is around security and connectivity for embedded platforms. So we've seen and we'll be talking today about, I'm sure, a lot of history and changes and trends in our industry, especially as it relates to securing the Internet of Things.
Hey, everybody. I'm Marcus Levy, President and CEO of Efficacy, which stands for the Embedded Microprocessor Benchmark Consortium, something that I've been doing for, since 1997. And actually, I'm relatively new to the security world here in IoT. Just a little bit of background on that. So for the last couple of years, I've been running a conference called the IoT DevCon, and clearly security was one of the most popular topics there. So out of that, I decided, okay, let's see if we can bring this into my main day job here, which is Efficacy, which is an industry standard organization that develops benchmarks, both performance and energy benchmarks for different types of embedded platforms, and the IoT is one angle of it that's, of course, very important. A new angle that we're starting up, and I'm encouraging people to join this effort, is a standard to figure out some of the guidelines for developing IoT security from the embedded product standpoint, and also to understand what the cost factor is associated with that in terms of how much performance does it take from the device, how much energy does it take from the device, because a lot of times this is an overhead feature, and so I put security on, and now all of a sudden my battery life goes down to nothing, trying to keep track of things. So anyway, that's the short story of what we're doing.
Hi, I'm Alan Grau, and I am the president and co-founder of Icon Labs. And we are also a company focused on security and embedded devices. We've actually been around for a little over 20 years and started out doing consulting work in the RTOS space, and really have taken that experience and utilized that to develop security solutions for deeply embedded devices, RTOS-based devices.
Thank you. My name is Warren Westrup. I'm with Verizon. I am Director of Engineering and Architecture for IoT and Security. My background, I've been in the business for a while. Been doing over private radio back with Motorola, and this has changed over time. We call it IoT now, but it originally started out as telemetry, and then we got a little more sexy with M2M, and now we're IoT. So, what I've seen over the last few years is that, you could do some things out there on the open internet, 5-10 years ago, and you really wasn't that much at risk. You put something out there now, within 45 minutes, somebody's either trying to hack into it or do a port scan. So security is I think, we were talking before, the design challenges, I'm not sure if it's been the forefront. It's starting to become more of a forefront, but security is paramount with the growth of IoT. I mean, it's a parallel growth pattern. As IoT grows, security's got to go along with it. So, thanks a lot.
Thanks, guys. So, just to step through quickly, at the end, remember your survey form. But what I thought we'd do is start with a couple of questions which we gathered earlier from the audience to warm things up a little bit. And then would certainly like to take as many questions as possible from the audience around the hot topics which are out there. So, the first question which we had come in is kind of an obvious one around security, and it's whether security is a cost or should be perceived as a cost in the system, or whether it's a valuable addition to the platform. So is security a cost or value? Who'd like to start?
Yeah, I'll start on this anyway. So one of the things that we've had a lot of conversations with our customers on this topic, and about 6 months ago really came to realize that while there is a cost to implementing security, and you talked about some of that in terms of battery life and obviously the engineering cost, that the way that I think people are, on the large OEMs at least, are pushing forward security is through a services model. We're starting to see a lot of the large OEMs, some of the network security provider or networking providers providing this as a service. And so that's, really flips the equation from it being just an engineering cost to something that's a true revenue opportunity.
Yeah, but when it comes down to it, though, the average consumer is not going to think twice whether or not the refrigerator has security implemented in it, because you just would never think this would be an issue, right?
Well, the refrigerator example gets thrown around a lot, and it's
toaster.
Toaster. Where we see people, I think we hit on this a little bit early on, was medical device manufacturers, industrial automation, OEMs. Certainly, automotive companies are seeing security as being a really important requirement, and so really those are the use cases that we're seeing driving security today. I think with time, as security becomes more built in, lower cost, that it'll start to show up more in the consumer side. But so far, in my experience, the consumer devices really are not adding security. It's the other markets that are driving it.
I think what it's going to come down to is that the OEMs or companies like Renesas who are building chips have to include security with the products that they're selling, because you see there's a lot of issues today with large OEMs, and the car manufacturers or the GMs or whatever, because they didn't think about implementing security on these things. But now you think about the gazillions of people out there who think, okay, I'm going to go build an IoT application because all I need is a microcontroller and a sensor and a RF piece of it, right? And you put it up there, and they have no idea what security is.
Yeah, I would echo that. Those comments, I think, to address this question, you also maybe have to break it down in terms of market segment, right? Maybe by show of hands, we could say, how many in the audience are in the consumer electronics space? would you say? Okay, smattering. Industrial and commercial? A few more, right? So that's where Alan's going. I think that's where really the sweet spot is for the IoT security business these days. And everybody else, you're just kind of hanging out at this session. You, sir, can you say what industry you're in?
I didn't know if that covered
Medical, right? Good. So that's an important point too, where regulatory issues come into play there as well.
I guess there's another question on what we mean by security and whether we mean security just from an application security perspective. I have a widget, I'm communicating to something, or whether we also mean security in terms of controlling our intellectual property, constraining manufacturing, and the value of security to OEMs themselves. So there's the two sides to security there as well.
Well, back to your point, ask the CEO of Target if it's a value, a value or a cost, right? So, when we go in and we talk to our customers that are deploying IoT solutions, they can buy extra level of security from us. They can do penetration testing, they can do security assessments, they could do credentialing on top of it. So, you just have to have the right conversation. So one of the questions is to the people that you're talking with is, what is the value to your business? What is the risk to your business if for some reason there's a breach? And those questions have got to be, this is it's a personal decision. It's kind of like, I kind of equate it to when you go to the rental car and take a rental car, you sign up for the extra insurance, right? You initialize the insurance or you don't. Right. And then so it's the same kind of thing with security when you're talking to your customers. You got to put it in their frame of mind.
So what about big data from that perspective as well?
Yeah.
Big data, we rely on the data being correct from source. What happens when it isn't? What happens when our devices have been compromised in some way or another?
Well, garbage in is garbage out, right? So that's where it's the key things that like ICON, intrusion detection, perimeter detection, being able to do things at the device level. Because if you look at a lot of the open development devices today, these are devices that are being certified for network, safe for network. If you look at them and you peel them back, there's not a lot of security in these things. They're especially if you look at it from a backdoor perspective. You may have a gateway or something like that, but the Zigbees and 6 low pans and all these other type of things on the backside side, tremendous hole that they could do a backdoor approach. But that's why like ICON. As far as being able to do trusted boot, secure boot, preventive malware injection, those kind of things are critical. And you're going to see more and more of that as time goes on, I think.
Yeah, and I guess the one statement had been made about companies like Renesas need to ensure that you've got hardware in at the security level, or security in at the hardware level rather, and that's a critical place to start. I don't think anyone would question that. But I was actually at a security conference and heard Renee James, who's the president of Intel, speaking. And as you all probably know, they now own McAfee or Intel Security. And she made the statement that Intel ships, over the last several years, has shipped hundreds of millions of devices with great hardware security that nobody uses. And the reason for that is the software wasn't there. The ecosystem hadn't caught up. So, it really has to be an end-to-end solution. It starts with, Hayden talked about over the last 12 months, you've been working with Renesas, building security into the Synergy platform. And then on top of that, adding the application pieces so that there is the end-to-end software security solutions that are easy to use.
Okay. Is there any feedback, questions from the audience? Anybody want to jump off on that one? At the back.
I don't want to lick my design magazine. One of the challenges with security is that it's a very large discussion. And even if you have, for example, a platform that has secure boot, that's not necessarily a secure system overall. For example, if you have bugs that are in the application that's running, you can still compromise the system. What do you run into when you're starting to talk to people and their customers and their customers' customers in particular when you're talking about consumer products. It's a very complex argument and challenge. How do you deal with that?
You want to run with that?
Well, I'll just real quick. So the question essentially was, security is a very complex challenge, right? Secure boot solves one problem, but you could still have application level security issues or application bugs that would allow buffer overruns that could lead to security problems. So how do you address that? And that's absolutely true. There is no silver bullet for security. I mean, we've seen, we're in the RTOS space, so the argument used to be, well, I've got an RTOS and it's way better than Windows, and I've got SSL, so I've got all the security I'll ever need. And I think the industry has moved past that and realized that more is needed. But there's still a lot of systems that have great security at the RTOS level. Maybe they have secure communication, but then an application with a wide open security loophole. So it really is a challenge that requires that end-to-end solution. Starting with the hardware level through the RTOS vendors, the application level security, but then it does have to include penetration testing so that that your applications are secure. A secure software design process. It is a very big challenge. There's no doubt.
Right, I would echo those remarks. In terms of the ecosystem, I totally agree. And what I kind of got out of your question, though, is what about the product in terms of, from power up to, when a datum is generated to when it, hits the cloud and everything in between. And, from that standpoint, I guess the kind of the model is, it's like your home, you want to lock all the doors, right? And so, you've locked the front door, but if you leave the back door open, somebody's going to find that vulnerability, right, in this case. So, secure boot is just, where it all starts, and that basically is a test that the genuine software that you're running. But the practices then, in terms of the application design, you begin to think about what you do with that data that's coming off of Zigbee or Cyclopan, encrypting that on the local file system, protecting and hash macking that data for integrity, so throughout its life cycle to the cloud.
I guess there's the question, a lot of people confuse security with encryption. And there's a requirement to take security more holistically, certainly from a system perspective, and think about the integrity of the platform, authentication, authorization, how you're going to manage devices over the life cycle, remote updates. All of these different components have to be thought of as well from that perspective. Do you guys want to add anything from those other perspectives? Or
Well, I mean, I look at it, encryption, yeah, that's a piece of it, but it's got to be a layered approach, right? I mean, you start out with, a private network, for one. Then on top of that, you can add, PKI and that kind of thing. Then you make sure your devices. The point is, it's complex, and there's a lot of things that you can. The more you do from a layered approach, the more secure it is. But this has been going on since the beginning of time. Hackers versus folks that are trying to keep it from being hacked on. So I mean, it's a constant struggle, right? So the more you can do from a layered approach, the more things that you can do. There's not going to be one simple silver bullet. I wish there was, but there's not.
Actually, I was going to ask you a question on that too. Is like how if somebody's building a product. Sorry, I'm taking the moderator's job here for a second, but how do they measure the efficacy of their security solution then? Because it is a layered approach, and the more layered it is, the more loopholes you could find. And
well, I think that the best way to do that is security assessments for one, and then a penetration test. Assessment is what is the overall risk of what you're deploying, and then a penetration test is more about what's the worst thing that could happen if you're breached, and then you actually try to see if you can't breach that for them. Those two things together, is really the way you prove whether or not it's really worth, Yeah, right.
And is there a role for certification in that, or is certification too tight a straitjacket?
Well, I was going to say one thing first is I think for some companies, the first thing you need to do is do something, get started, right? I mean, it's surprising how many products are out there that have either no security or so little security that it's not really worthwhile. So I think, there's, we're talking about all the layers of things that you could do, but we're still seeing new products come to market that haven't done the basics. So I think that's the first thing is, are you locking down ports? Do you have some level of encryption, some level of secure boot? Are your communication channels secure? Do you not have any back doors? Are you required? We did a security audit for a company this summer, and we found that they had secure or firmware update, FTP. You could push software to it, no password, no authorization whatsoever. And this was going into the oil and gas industry. So, that's kind of the first step. Yeah, and it's surprising how many people just aren't doing that. We've got a couple questions.
Yeah, but on the security question here is this is one angle that we thought about too. Is in addition to measuring the the performance aspect or performance requirements of security, is there a way that we can actually do certification on it? And I guess one of course is it's really complex and requires a lot of expertise to figure this stuff out. Second point is, is this something that a government agency should actually be involved in? Because it's, it's a big topic. But also from a private standpoint, what if you certify a product and, you're never going to be 100%, right? And so you certify an important product and somebody hacks it and somebody dies. We don't want to get sued, right? Yeah. So it's kind of a full. It's meant to fail in a way.
Sorry.
A lot of IoT are using cellular as their connection rather than Wi-Fi. Is one better than the other or more secure than the other?
Well, yeah, so he says, a lot of companies are using it in cellular or they're using Wi-Fi, for Internet of Things and connectivity, so which one's better? I can only speak for Verizon. I can't speak for the entire industry, but we do a lot on network security. I would think, my belief is we have, intrusion detection in our networks. We're constantly looking for any kind of breach from a network standpoint. That doesn't mean we can protect every device because devices, they're regulated. We can make sure that devices that are certified on our network will not harm our network. But we can't necessarily dictate what specific security the customer has to put on their device or their application. That falls into FCC and regulatory and open access. So we just got to make sure that our network's not breached. So, from our standpoint, we spend a lot of time on network security, making sure that our network's safe. Like I said, intrusion detection, watching for things, abnormalities. So, in my opinion, I'd like to think that the cellular network is way more secure. Not only that, when you start talking about LTE, the RF layer is AES encrypted. So there's a lot of things that go into the cellular network to make sure that it's secure. Obviously, it's more costly though.
But
right?
you guys have been doing that though before IoT was invented, right?
That's correct. So
nothing new.
Nothing new.
The counterpoint, though, is I think the Chrysler Jeep hack, right, which was across the cellular network. So if you're going to have devices on a cellular network with useful IoT functionality, you will have openings for potential cyber attacks. I'm not saying one is, it's therefore less secure.
I think that happens either way, though, right? That happens either way. And it goes back to, how well is the customer actually, protecting their device. This, the cellular network is secure, but if there's a backdoor through, Zigbee or Bluetooth, there you go,
Sorry. Yep.
So my question is, you talk about a systemic security where you do a lot of looking for anomalies and things. That already implies that you're breached. If there's an anomaly on your network, you're breached, and it's a matter of reaction. In the embedded world, which is a lot of what we're talking about for IoT, do you have to secure every point of data generation and data reading? I mean, does every sensor microcontroller need to be a secure microcontroller? Or is there a systemic way that you can use secure microcontrollers in a system to make the whole system secure without having to implement a security function on every point of data collection and generation?
So the way I heard that is if you use secure microcontrollers on the endpoints, well, then you have implemented security on all the endpoints. Right? So, I mean, to me, really, ultimately, the only way to ensure that everything is secure is that all the endpoints would have to have a security function on them. Obviously, the security function in an 8-bit MCU that's controlling, or only reading data as controlling a sensor, is going to be far different than in a gateway connected to the Verizon network that also has Wi-Fi connectivity and is doing a lot more things. But, I mean, our approach, and again, is, I'm a security vendor, so this is coming from my point of view, but you really do have to have some level of security in everything.
So I think there's a trade-off there as well, though, around cost, isn't there? So some devices need a small amount of security or can be behind a firewall, or the cost of a compromise is low, whereas in other applications the cost of a compromise may be catastrophic, and therefore you have to build the security to the right level. So it's all about threat analysis and building the right protection against both the threats that you're going to face and the type of attacks as they evolve.
Yeah, I mean, and that's a really good point. So, I mean, everybody's building these little SoCs or whatever for IoT applications, and it doesn't take much silicon these days to put security monitoring functions on the chip, you know, which is probably even cheaper than the amount of memory it would take if you did it all by using security software algorithms, right? Okay. So there's a variety of things that have to be considered, and of course, you know, do you have a way to monitor the data that's stored on the chip? Is that locked out? Do you monitor it while the chip is actually doing the processing, doing the communication aspect of it? And you know, I mean, encryption is really the bottom line first thing that people have to do, and making sure that the public key or the key that you're using for the encryption is secure in the first place. So,
okay, so we've got 15 minutes. So let's. Sorry, we'll come back in a second with the gentleman in the middle there.
Hardware designer. So from my perspective, minimize costs, up to sales and marketing to add value add, try to sell it to the customer. So, and also from my perspective, I have to choose a microprocessor and some kind of Wi-Fi thing, both those together. So could you like maybe recommend an engineering kind of cheat sheet or something of things I should be looking for when I'm trying to identify the processor and the wireless thing to start building my IoT widget?
Well, thanks for the softball there. Of course, we're going to recommend Renesas, right? I just to kind of build on that concept. Beginning to kind of formulate the kind of a viewpoint where you've got different security profiles, right? And so at the lowest end, you've got an 8-bit micro or whatever. Maybe all it does is channel encryption, but perhaps not authentication. Then the next profile 1, 2, or whatever has stronger and stronger security models, I guess. Yeah. So maybe to address your question, it sort of depends on what product you're intending to build and what market you're going into, especially if there's specific regulatory issues or requirements there for data, HIPAA in medical or what have you.
Yeah. To add to that one, there's a great webinar coming out around the new synergy platforms from the S1 to the S7, which I'd recommend as a great cheat sheet. I helped record it. So. Okay.
Examples of best practices that you see out there?
Want me to lead off on that?
Sure.
Okay. Again, I go back to medical. So we've just recently completed, through a customer product cycle where they've gone through, they've done some medical dispensing, I guess it is, right? So, their concerns are, that their system is, through pen test to, check for security vulnerabilities where, a hacker could get in and dispense some, some drugs, right? So they've gone through a process where they've, best practice, done the security audit, number one, right? Found vulnerabilities, number two. So essentially they had a priority checklist of things, gaps that they wanted to close, right? And that's what they did. So they had channel encryption, number one, with SSL, okay, industry practice. Number two, there was mutual authentication that they needed to add there through PKI or X509 certificates. So device level authentication can be achieved through that standard. Yeah. Okay.
Yeah, I mean, another area in industrial automation, there's the ISA and EDSA, I think it's 62443 security standard that a lot of industrial automation OEMs are following. So, I mean, there are a number of standards out there or best practices out there. I mean, those are two, if you look at the different industries, I mean, NIST has its cybersecurity framework that they publish and specify for certain things. So a lot of these, if you boil them down, come to a lot of the same elements. So even if that doesn't specifically apply to your industry, the concepts and elements of it really are the same.
Mm-hmm. There is also some good guidance from Homeland Security and the Center for Protection of National Infrastructure. If you can find it on the web, they don't necessarily make it very easy to find, but if you can find it, it's worth a read.
Secure.
It's very secure. It's very secure. Sorry. Some more questions from the audience.
Everything I've heard so far has been about software security in the virtual world. It's being done in the physical realm in terms of tamper detection and prevention, like from the chip, for instance, detecting the flash to detecting if someone tries to drill into the chip or penetrate the package of a product.
So, yeah, I mean, that's really an interesting question. I mean, so the question is, what about physical security from somebody trying to crack the cover open, remove the flash and read it, or the tampering of the product? I actually had a conversation with someone at a conference, 3 or 4 months ago, and they were working with a government contractor, and there they were concerned about people having seals on the product, so being able to basically sand off the cover of a product and then insert probes and read physically from the device to try to read from memory and do countermeasures for that. So this is, I mean, the comment was made earlier that I refer to it as an arms race, right? So that's where the assessment starts out. What threats are you protecting against? And not only are you worried about protects over the cellular network, the Wi-Fi network, local physical attacks, the sophistication of the attacker, but there are hardware level capabilities that can be implemented that will detect if somebody removes a cover, or that provide a mesh covering it's electrically lit over the cover, that you can actually detect those sorts of things. And that's really where it becomes a cost question. How much does it make sense to invest? If it's an 8-bit micro-controlling a Zigbee sensor, well, you probably don't care about that. If you're building something that's controlling nuclear missiles, you probably do. So there's a huge range of considerations, and but that is one important one, and we've definitely seen hardware vendors that are providing the hardware level capability to support that sort of tamper detection.
I think there's a component to this as well, which is, as you say, the threat analysis, but also the way that systems are architected, such that if you tamper with a single chip, you have perhaps compromised that single chip rather than a class break. And if you can architect the software correctly, then in many cases, tamper resistance isn't such an issue anyway.
I know that some of the other ARM vendors will have a capability of some type of, the chip is penetrated or tampered from a physical point of view, that it may even self-erase, for instance, the certificates for the SSL.
Yeah, like TPM, like a trusted platform module or something like that.
Right, is there anything like that, the Renesas one?
Yeah, exactly. Yeah, that's the other thing. But it does add extra cost into everything, right? That's what it boils down to.
Depends what the data's worth.
Exactly. I'm with you. No, I agree.
I think you said that.
Yeah, I agree.
So Well, the question was, is that something
also-
that Renesas has support for? Was that the last part of your
Yes.
question? Hayden, you're probably better positioned to answer that, whether or not that's part of the tamper detection.
It's in terms of the hardware security. I think that's not quite such an area of focus at the moment, but I think it's something that I'd probably refer back to some of the Renesas guys, such as Nick, who sat at the end of the row over there. But I think that's one perhaps to refer back to Renesas themselves over this week.
But your question too, I mean, is not something that's new to IoT, right? This has always been an issue in many industries, and I don't think the technology has really evolved any further than maybe the last 10 years on the tamper.
Well,
Things like credit card processing terminals.
well, I think even the strongest secured tamper-resistant devices have been defeated. If you have enough resources, you can defeat practically anything. It's just how much resource are you prepared to spend to win that device. So you can go and buy a fibbing machine for what, $7,000 on eBay? I know a guy up in the valley who has one in his garage. He likes taking apart stuff for the fun of it. People do that in the Far East. I know they teach courses in how to fib physical tamper-resistant devices. Stuff gets broken. The challenge is to make sure that when you break it, you break that single device, and therefore the effort isn't worth it. That would be my view.
I guess the other thing I would say on that is for 98% of the OEMs, the challenge is don't be the low-hanging fruit. Because if your device is really, really hard to break, they're going to move on to something else.
Mm-hmm.
Now, there are exceptions to that, right, where you really have to think about those things. But for most people, if you can set the bar higher than, what hackers are willing to, invest, then you've really done what you need to do.
I think we've got time for one or two more questions. Yes.
Regarding security, usually the weakest point is always the user, being it by putting a sticker with the password in front of the monitor, being on a industrial level, the chief of maintenance by sticking an access point to the maintenance serial port of the plant. And as much as safety for security, as long as it's uncomfortable for the user to have it, it's not seamless, the user will trespass it. And safety may have a two-hand device on a press, but the operator will always try to bypass it, even at risk of losing his hand. At security, the idea of loss is much less, it's only data. How is it being dealt with in order to make security more seamless for the user, less inconvenient?
So the question was, security is not always convenient for users, and users are the weakest link, right? People will write their password, stick it under their keyboard or on their monitor. So what are we doing, or what is the industry doing to make it easier for users, to make it more seamless to bypass those problems?
Well, in the application processor domain, things like FIDO, Fast ID Online, are coming through. I haven't seen that operating so much in the IoT domain yet, but certainly if you look at Intel and Apple and the other people there supporting FIDO as a standard as we move forward.
Yeah, we're very close to that actually, because one area, as you've mentioned, is FIDO, and that was actually my very comment. When it comes to users, right? FIDO is all about authenticating the user and then fighting password fatigue, right? So basically, the user experience is to enter the password once, and then basically at that point you probably know then you've got an authentication token, a physical device that you'll use for multiple websites, right? So, hooray, the end of passwords. Not exactly, but password storage then is secure on that device. When it comes to the IoT device space, though, that's another thing entirely, because there's really not a user there to authenticate, right? So I think in terms of industry practice, what we are working on with today, what we have to work with today is X509 PKI device level authentication, right? And that actually works pretty well.
Yeah, we were just saying the same thing. We definitely agree on that.
Okay.
Yeah. I guess the other thing is if you look at with iPhones with fingerprint scanning, more and more biometric authentication capabilities as they get to be easier to use and more reliable will also be part of the solution. But it is, there's a lot of integration work to be done. There's a lot of end-to-end issues to be solved that we all have to work together to get solved over time to make it easier for users. There's no question that the human element is still, and for quite a while to come, will undoubtedly be the weakest link.
Okay, any final questions? Okay, so perhaps very quickly off each of you, what would be the one thing that you would change around security in the Internet of Things? What would you make better?
I think, what I seem to find out is usually security is always added after the fact. My thought is, that needs to be up front. You really need to start thinking that through at the very beginning and not try to, patch it after it's over with.
Yeah.
That's what I see.
Security first.
No, I would certainly echo that. And then the other thing I would say is, as you're looking at that, is to get started. Put a roadmap together. And even if you're not doing everything today, make sure that you've started on your security roadmap and have the basics in place.
And actually, I have to echo that too. But to add to that, I think it's kind of on the onus of the chip manufacturers and the people who are providing the components to educate the industry that security is an important aspect and to make it easier for people to use it without a major cost impact on it, because otherwise people will not do it because cost is everything.
Okay. Steve?
Yeah, not a lot that hasn't already been said, but again, the product requirements document is really central to this. Put the security on there and, be ready to make a cost justification for it, because there is a benefit and an upside to making your product successful in the market with that.
And you all missed the softball, which is, of course, to look at Synergy as the platform. Absolutely. Okay, so I think we're out of time. Thank you very much for your questions, for your attendance. Thank you.